Building massive multiplayer games or autonomous AI agents on today's blockchain infrastructure doesn't work. When these high-performance systems run on-chain, they hit a rigid wall. The problem is rooted in how traditional smart contracts process information. Every single node in the network is forced to calculate the exact same deterministic math. If thousands of nodes have to duplicate the same complex rendering or AI logic, the network grinds to a halt. To fix this, developers use modular Layer 2 systems, gluing together disparate pieces, data layers, sequencers, and security protocols. But multiple independent systems compound latency and security risks. A vulnerability in any connection brings the application down. But Kira takes a completely different path. Instead of patching together a fragile stack, it introduces a unified architecture called hypermodularity, bringing all necessary infrastructure under one roof. To reach the cloud computing power and scale of Web 2, while keeping the security guarantees of Web 3, the industry has to stop fragmenting its infrastructure and start consolidating it. Kira's hypermodular approach integrates execution, data availability, and DevOps under a single security umbrella. It is a completely self-contained network. 4 native layers, SEKAI for blockchain, INTERX for data, RYOKAI for DevOps, and MIRO for front-end, form a unified stack. Developers code in any language inside isolated Docker containers. These RollApps plug directly into Kira's backend, gaining immediate access to scalable hardware. By stripping away the burden of infrastructure management, hypermodularity lets developers focus entirely on their application's core logic. Before any newly deployed RollApp can actually begin running, it needs 2 things: initial capital and a guarantee of network security. Kira's Initial Liquidity Offering, or ILO, is a crowdsourcing mechanism. Stakeholders commit the native token, KEX, to bootstrap day 1 liquidity. In return, the protocol distributes liquidity provider tokens back to participants, creating a continuous economic loop that sustains healthy markets and rewards node operators. The base network is secured through multi-bonded proof of stake. This consensus allows users to stake diverse assets like Bitcoin, Ethereum, and NFTs. Crucially, Kira natively issues liquid staking derivatives for all bonded assets, returning liquid tokens so capital isn't locked up. Together, the ILO and multi-bonded proof of stake form a dual economic engine. They guarantee deep application liquidity and robust base layer security, all while keeping user capital entirely fluid. Once an application is funded and secured, execution begins under the governance of the Virtual Finality Gadget, or VFG. Most optimistic rollups assume that computations are correct by default. Kira takes a pessimistic approach. It automatically assumes all execution results are incorrect until they are actively proven otherwise. Node operators, called executors, process the rollapp's logic during rapid sessions, leaving the output unverified. To confirm the work, Kira relies on fishermen, an uncapped, permissionless swarm of independent verifiers whose sole responsibility is auditing the executor's proposed changes. Curious, engaging tone. These fishermen aren't forced to use identical verification math. They can deploy highly customized private rules, even using AI agents to monitor for exploits. Because these checks are private, it is virtually impossible for an attacker to predict how their code will be audited. The accountability is strictly enforced. Executors lose their operating status and income if they act maliciously. On the flip side, if a fisherman falsely accuses a perfectly valid executor, their staked bonds are slashed. By separating the intense processing of execution from the stringent rules of verification, Kira creates a trustless environment where corruption becomes mathematically and economically unviable. By separating the heavy work of execution from the rules of verification, Kira changes the math behind the blockchain trilemma. Because every node isn't forced to re-execute every block, the network can scale its hardware without sacrificing the decentralization provided by its permissionless swarm of verifiers. This architecture makes a significant shift possible. Non-deterministic applications, like AI agents generating unique, unpredictable outputs, can now safely exist on-chain. This works because verification no longer requires exact mathematical replication across every node. The fishermen simply need to confirm that an application's output falls within collectively agreed-upon boundaries. For network users, the result is a seamless experience. They can bridge assets, earn staking rewards, and interact with applications through the MIRO frontend, getting Web 2 level quality without sacrificing Web 3 security. For developers, it means the freedom to deploy complex, Docker-based code in any language, supported by guaranteed liquidity and hardware that scales on demand. Kira moves decentralized architecture away from fragmented obstacles and toward a unified, trustless cloud computing network where applications can finally function at a global scale.